tree level. So in this video, what we are going to do is, after having talked about secondary storage management and disk magnetic tapes as well, we are going to talk a little bit about disk scheduling algorithms. Okay, so before actually jumping on to talk about all the scheduling algorithms that we have present, we'll first talk about this concept in a little bit detail. Okay, so what is disk scheduling? Okay, so the very idea is that disk scheduling is basically done by operating system to schedule input output request which is arriving to the disk. Okay, so it is basically used to schedule the input output request which are arriving to the disk. Okay, that is why disk scheduling is also known as input output scheduling. Okay, now why exactly is disk scheduling important? Okay, we need to talk about that as well. So the idea is that multiple input output request, okay, may arrive by different processes. Okay, since if we are in a working in a multi-processor kind of an environment, it is very common to have requests in which multiple processes are trying to make request for an input output. Okay, whereas the disk scheduler can only process one request at a time. Okay, that is why, since the disk controller can only take care of one request at a time, other input output request by the processes needs to wait in a waiting queue. Okay, and that is why after they have been waiting for some time, and when the disk controller is free, we need to schedule those requests as well. Okay, so we need a mechanism, because a lot of processes input output request must be waiting. We need to have such a process which can be used for the scheduling of the disk operations for those waiting processes. Okay, that's what the very first purpose is. The second purpose is that two or more requests may be very far from each other. Okay, and so can result in greater like disk arm movement. Sometimes there are two requests that are coming for input output which are very far from each other and leads to a greater arm movement. Okay, so that is why proper disk scheduling is required. And apart from that, hard drives are actually, to be honest, in when we put everything in terms of a storage architecture and hierarchy, hard drives are actually the slowest part of the computer system. Thus it is very important that the scheduling of the request is done in the most efficient way possible, so that there is no, I would say, latency, or as less latency as possible. Okay, so a total of three reasons that we discussed over here. Reason number one would be that since a lot of multiple requests are coming from multiple processes, and many of them can request for input output, thus, but the disk controller can only schedule one request at a time. That is why all the other processes have to wait in a queue. Okay, and since they have to wait in a queue, that is why we need proper mechanisms so that their scheduling can be done in a proper way. Second thing is that if there are two or more requests which are very far from each other in the disk, right, that can actually lead a lot of disk arm movement. Okay, and the third part is that hardwares and like hard drives are actually one of the slowest part of the computer system. Hence it is very important that we do the scheduling in such a way which is very efficient and can lead to the efficient processing of the input output request. So there are a lot of, I would say, scheduling algorithms available. Okay, but before actually moving on to our first algorithm, you have to understand a few terminologies as well over here. We have touched upon them a little bit earlier, but it would be good to introduce them now as well, so that we have proper understanding. So this will be rotational latency, and the third would be transfer time. Fourth would be disk access time. And fifth would be the response time. Now, what are actually all these terms? Okay, so seek time is basically the time that is taken to locate the disk arm, okay, where exactly your request answer is, right, or where you're actually looking at the location, right? So the time taken to locate the disk arm, okay, to a specific track, because a disk has a lot of tracks, right, where the data is to be read or written. Okay, either you read the data or either you write the data. Okay, so the disk scheduling algorithm that gives the minimum average seek time, the better the algorithm is. So what exactly is seek time? Let me put this down a little bit. Seek time is basically designed at the time taken to locate the ARM disk to a specified tracks, because on a disk there can be a lot of tracks to specify or to go to the specified track where we have to, or where the data, okay, is to be read or write. Okay, and the minimum this average seek time, the better the algorithm is. The better the algorithm is. Okay, that's what rotational seek time is. Next, what we have is rotational latency. Okay, now let's say you have specified the track, okay, where exactly your information is present. Okay, but on a track also you have a lot of small sectors, right? A track is also divided into a small sector, so you have to move on that track. Okay, your arm head, okay, or your read write heads basically have to move on that track to basically reach to the desired sector where exactly your read and write operation will be done. So after reaching to the tracks, you also have to move over the track to reach to the desired sector where your information is to be read or read, and you have to make sure that your read write heads are exactly above that sector so that we can transfer the information. Okay, so we basically understand rotational latency as the time taken by the desired sector of disk to rotate into a position so that it can access the read write heads. Okay, so the minimum the rotational latency, the better the algorithm is. Okay, next what we have is the transfer time. Okay, so what happens in the concept of transfer time is, now let's say you've identified the correct track also and on that track you have identified the correct sector as well. Okay, now after identifying the sector and the exact position where you have to do the read or write operation, it will take some time, right, to transfer the data. Okay, and the time it takes to transfer the data basically depends on the speed of the disk, okay, and the number of bytes also that needs to be transferred. So the time taken for that transfer process is known as the transfer time. Okay, so this is known as the time taken to transfer the data. Okay, so here it basically depends. It basically depends on the rotating speed of the disk, right? As well as the number of bytes to be transferred. So this is what transfer time is. Next, let's basically talk about disk access time. Okay, so what exactly is disk access time? It can be defined as the summation of seek time plus rotational latency, right, to locate the sector plus the transfer time. So the summation of all the above three times basically gives you the disk access time. Okay. And what is disk response time? Response time, we can say, is basically the average of the time spent by a request. So here disk access time basically starts with the very time where your request is supposed to be start getting processed, whereas response time also includes the time where the request is waiting to basically perform the input output operation. Okay, so average response time is basically the response time of all the requests. Okay, or here this is also known as disk response time. Okay, and here we have basically multiple algorithms present to take care of this. So the process is usually like this. So you have like how does it work is basically you first have a disk delay, because this controller can only take up one request. So there's like a lot of queuing that is happening. After that, once you actually are given the time to get processed, you have a seek time. Then you have some rotational latency, and then after that you have the transfer time. Okay, so basically disk access time is this. Okay, and this is the disk response time over here. Okay, response time is basically the average of the time spent by the request waiting to get its input output operation performed. So this would be the entire knowledge that you need to have before we actually move on to understand the disk scheduling algorithms. And now we have a lot of algorithms available. We have a first come first serve algorithm. Then we have a shortest seek time first algorithm. Then we have the scan algorithm. Then we have C-scan algorithm, and then we have look algorithms as well. So in this video, we are going to talk about all the five. In this video, we'll just talk about the first one, and then in the videos after that, we'll talk about the rest of them. So what all scheduling algorithms we have? First, we have first come first serve. Then we have shortest seek time first. Then we have scan. Then we have C-scan, and then we have look. Okay, I'm sorry, I was not on the screen. So these are all the five, I would say, scheduling algorithms which are available and which we will talk about. So let's start our discussion and talk about the first scheduling algorithm. And remember, by the name itself, you will be able to understand a lot of how that scheduling algorithm works. So the simplest form of scheduling is first in, first out. Okay, where the processes are actually executed, or the requests are processes from the queue in the sequential order. That means whichever request is coming first, that request is getting processed first, and it does not depend on the fact how much of the time it is taking to actually go to that sector, or I would say like the track, and it doesn't depend on that. Okay, so it is the simplest form of scheduling. Okay, where requests are basically processed in the order they arrive in the disk queue. Okay, so here you can actually take an example to understand this. So here we've actually marked the numbers. Okay, And you can think of it like this, that the head pointer, the read write head, let's say initially is at 53. So the first request comes for 98, then it immediately jumps to from 53 to 98. Then the request comes from 183 and then it goes all the way to 183, irrespective of the fact whether it's moving like clockwise or anti-clockwise. Then it is 37 and then it goes all the way to 37. Okay, and then here it goes all the way to 37 to 122 and then to 14 back and then to 124, then to 65 and then to 67. Okay, so based on how the requests are coming over here, right, we are basically processing the answer in this case over here. Okay, let me show you another example for first come first serve. Okay, let's say here we have 0, 16, 24 over here. Okay, and I'm just taking random number like 43, 50, 82, 100, 140, 150, 170, 190, 199. Okay, and here let's say the requests ordering is like 82, 170, 43, 140, 24, 16 and 190. Okay, and initially the head is, let's say, at 50. So the head is at 50. From that we are going to move to 82, right? Then from that we are going to move to 170 all the way. And then we are going to move to 43 over here. Then we are going to move to 140 over here. Then we are going to move all the way back to 24 and 24, and then we are going back to move to 16, and then we will go all the way to 190 over here. Correct? So how do we calculate the total seek time over here? Right? First of all, here the seek time would be to go from 50 to 82. So the seek time will be 50 minus 82. Okay? Or 82 minus 50 in fact. Then we are going to add it to 170 minus 82. Okay? Plus then we are going to do over here 170 minus 43. Okay? Plus what we are going to do is 150 minus 43 or 140 minus 43 plus 140 minus 24 plus 24 minus 16 plus 190 minus 16. Correct? And here the answer comes out to be 642, which is the total seek time over here. Okay, and that's what the first come first serve scheduling descheduling algorithm is. Okay, now to talk a little bit about a few advantages of using this approach, right? The first is that each request gets a fair chance, right? Because there is no partiality, there is no priority. The second thing over here is that there is no infinite or indefinite postponement, right? No process is basically postponed over here, let alone indefinite. Okay? But the disadvantage of using this algorithm is, first of all, it does not optimize seek time. It does not take into consideration at all the seek time of the algorithm. Okay, it just works on a first come first serve basis. Okay, and it may or may not be the best choice. Sometimes luckily it may be, okay, but sometimes it may not be as well the best choice while coming up and talking about, I would say, a scheduling choice. Okay, so this in turn helps us to understand the overall idea about the first scheduling algorithm, which is first come, first serve. I hope this is clear to everyone. We took 2 examples also in order to understand the topic in great detail and with better clarity. And now we are going to move to talk about the second algorithm in the next video and the rest of the algorithms as well. Okay, so stay tuned, keep practicing, take examples some yourself as well for better understanding, and I will definitely meet you in the next video. Bye.